Okay, so parallel lines and transversal. So, a little bit of vocab that we already are pretty familiar with. Parallel lines, we know that those are in the same plane and they never intersect, right? And then perpendicular lines, they do intersect, but what type of angles do they intersect at? 90 degrees, okay? So let's go ahead and define what we know or what we think parallel lines are in our own words. So what would you say parallel lines are? Casey? Two lines that never touch, okay? So if I want to draw a set of parallel lines, how do you think that looks? Does it matter? Do they look a specific way? They can go in any direction, right? They just can never touch. So are those parallel? Yeah. Somebody raise your hand and tell me a real life example of parallel lines. Abby. Railroad tracks. So, okay, so you basically, there's multiple different parallel lines in a railroad track, right? The actual railroads that the train goes on, and then the ties that go in between, right? Okay, good. What else? Yep.
Like the yellow line on the road.
Good. A double yellow line in the middle of your road. Okay, so those never touch. They are parallel. One more example. Drew. Okay. The legs on your desk, I'll take it. The front legs, right? The back legs are angled a little bit, so if they extended forever and ever, they probably would end up touching. All right, so you can write any of your examples right there. I'll just say a double yellow line on a road. So what do you think parallel lines are? Define that in your own words. Sorry, perpendicular, yeah. Casey? Okay. Two lines that intersect at 90-degree angles. We'll say two lines that meet. A little shorter. So if I wanted to draw a pair of perpendicular lines, what do they look like? Nick? Kind of like an X, right? And if they're all 90 degrees, then they all have this little box. Okay. What is a real-life example of perpendicular lines? Nick? Railroad crossing sign. Okay. What else? Look at the ceiling. Do you see perpendicular lines?
Ceiling tile.
Mm-hmm. What about a cross? Is a cross perpendicular? Did that steal your answer? So there's perpendicular lines lots of places. Brian? The bricks? Yep.
This isn't really a line, but it's like a four-way turn.
Okay. A four-way stop if you extended lines throughout that road. The road, actually. I mean, I guess the road would be perpendicular. Okay. Nick?
There's four states that are connected.
For what? Yeah.
Look at it on the map.
Maybe on a map. But technically, they're probably not perpendicular. All right, last one. Okay, Drew.
Pyramids. I mean,
That has like the little wraparound thing on it. Okay.
No, like the first aid kit.
Oh, yeah. The little red plus sign.
Yeah.
Or whatever it actually is. Yeah, that's perpendicular. Okay, so let's go ahead and flip over to the back. We've got lots and lots of vocab. Okay. So looking at transversals and angles, we've got all these vocab words that are very important that we need to know. First of all, we have a line that intersects two or more lines is called a transversal, okay? So looking at the picture right here, these are two parallel lines. This line that's crossing those parallel lines, that is called a transversal. And when that happens, it forms 8 angles, okay? So two parallel lines with a transversal in the middle forms 8 angles. And then we're going to learn about those 8 angles. So first of all, I have interior angles. So interior means inside, right? So it means that all of the angles that are inside of those parallel lines, those are interior angles. So angle 4, angle 3, angle 5, and angle 6. Those are interior angles because they lie inside of those parallel lines, okay? Exact opposite from that is your exterior angles. So your exterior angles lie outside of those parallel lines. So angle 1 and angle 2, and angle 8 and angle 7. Those are your exterior angles, okay? Then we have alternate interior angles. So interior angles, I already know it has to be these angles that are inside of these parallel lines. But if they're alternate, then that's telling me that they are on opposite sides of that transversal, okay? So angle 4 and angle 6, see that they're on opposite sides of that transversal. So they're alternate. And then they're alternate interiors because they're inside of those parallel lines. Does that make sense? So angle 4 and 6 would be alternate interior angles. And then angle 3 and 5 would be alternate interior angles. Okay. What do we know about alternate interior angles? We know that when those lines are parallels cut by the transversal, alternate interior angles have the same measure. So angle 4 and angle 6 have the same exact measure. So if angle 4 is 20 degrees, then that means angle 6 is also 20 degrees. Okay. So alternate interior angles have the same measures. Okay. Then we have alternate exterior angles. So alternate, remember they're on opposite sides of that transversal. And then exterior means they're laying outside of those parallel lines. So 1 and 2 and 8 and 7 are exterior. And then alternate means that 1 and 7, they're on the opposite side of that transversal. So 1 and 7 are alternate exterior angles. What's another pair of alternate exterior angles? What is it?
2.
Good. 2 and 8. Okay. So when this happens, if we have alternate exterior angles, their measures are also equal. So the measure of angle 1 and the measure of angle 7 are congruent. They're the same. Measure of angle 2, measure of angle 8 are congruent as well. Okay. One more type of angles we have here. We have corresponding angles. So that means that they are in the same exact position on those two lines in relation to the transversal. So if I look at angle 1 and angle 5, say that I split it down the middle right here. Are they in the same position? Yes. So those are corresponding angles. Okay. 2 and 6, they are in the same position. So they're corresponding angles. 3 and 7 are corresponding angles. 4 and 8 are corresponding angles. Okay. So what do you think we know about the measures of corresponding angles?
They're all the same?
They're going to be the same as well. Okay, so let's see why all these angles actually are equal. Okay, so if I have my let me zoom out a little. If I have my two parallel lines that are cut by a transversal, so here's my picture. Okay, my two parallel lines. My line L is my transversal. So remember, when that happens, it forms 8 different angles. Okay. If I cut those two parallel lines apart, so if I take them apart, remember we said that angle 1 and angle 5, those are corresponding angles, so they have the same measure. But why do you think they have the same measure? Once I cut this apart, if I overlap them, are they the same exact thing? Do you see that? If I take this one and put it on top, I have the same exact lines. Okay? So, that is why I can say that angle 1 and 5 are congruent. Angle 1 and 3, angle 1 and 7, those are congruent. Angle 1 and 3 also, okay. So when I overlap, it's two lines, my two parallel lines. When I cut them by the transversal, if I cut those two apart, they are exactly the same lines, okay. So does that make sense? Why that all these different angles have the same measures? Because technically this is the same exact thing as this, but when you put them together, they're still the same. Does everybody see that? Okay. So, side note, which we already know this part, we already know that this square right here tells me it's a 90-degree angle. So if you see this, that tells you that those two lines right there are perpendicular, okay? This we haven't seen before. These are two parallel lines. If you see this little colored triangle on those lines, that tells you for a fact that those are parallel, okay? So that means that they're parallel lines. Okay, let's look at some examples. Example number 1 says to classify each pair of angles in the figure as alternate interior, alternate exterior, or corresponding. So looking at this picture, number 1, they want us to tell what angle 1 and angle 7 are. So looking at angle 1 and 7, I know that they both lie outside of those parallel lines. So I know that there's some type of exterior angle. Are they on opposite sides of that transversal? Yes. So they are alternate exterior angles. Okay. And then number 2 is asking about angle 2 and angle 6. So what do you think angle 2 and 6 are?
Congruent corresponding?
Corresponding, yeah. They're corresponding angles. So remember, if I cut that in two right there and I place them right on top of each other, 2 and 6 would be in the same exact spot. So those are corresponding angles.
It's also a
Okay. Yes. Questions on that? All right, flip over and let's do A. Example A. It says classify the relationship between angle 4 and angle 6 and explain. So that means sentences. Okay. All right, so we're looking at angle 4 and angle 6. So what do we think, what type of angles do we think those are? Interior. What else are they though? They're alternate, right? They're both on opposite sides of that transversal. So those are alternate interior angles. Okay. So they are alternate interior angles. Alternate. And I know this because why? We just explained it. Starts with a T. Transversal. Because they're on opposite sides of the transversal. And what else? What else tells me? That tells me that they were alternate. How do I know that they were interior? Because they're inside the two parallel lines. So I know that they're alternate interior because they're on opposite sides of the transversal and they're both inside those parallel lines. Any questions on that? We got that copied? Okay. So just like when we learned about complementary and supplementary and vertical and adjacent, we took that information that we learned and we were able to find missing measures, right? Missing angles. So we can do the same here. So if they give me an X or if they give me just the value of one measure, one angle, I can find everything else. Okay? So it tells me right here, and I want you to underline this sentence. If you know the measure of one of the angles, you can find the measures of all of the angles. So all you need to know is the measure of one angle, and then you can tell me every single other measure. Okay? And we're about to see how that works out. So looking at this picture, they tell me that the measure of angle 1 is 50 degrees. So now that I have that one measure, they're telling me I can find every single other angle measure on there. You think we can? Okay, so what about angle 3? Can I go ahead and say what measure that is?
Yes.
What is it?
130.
Angle 3?
Angle 3 is 130.
Angle 3 would have to be 50. What do I know about those two angles? From previous lessons, not from today's lesson. Those are vertical angles. And what do I know about vertical angles?
They're the same.
They have the same measures. They're congruent. So that's how I can go ahead and say that angle 3 is 50 degrees. So angle 1 and angle 3 are congruent. Okay? How can I go on to find angle measure 4? Mm-hmm. Andrew?
Is it straight?
Because it's a straight angle, subtract it. Subtract 180 by 50.
Okay, so I know that 1 and 4 together make this straight angle. So they're supplementary, right? They add up to 180. So I can say the measure of angle 1 plus the measure of angle 4 equals 180. So when I subtract 50 from 180, I get measure of angle 4 is 130. Okay. And then I can do the same between measure of 1 and 2, or I can go ahead and say, oh, I found measure of angle 4. 4 and 2 are vertical angles, so 4 and 2 have the same measures. So that tells me angle 2 is 130 degrees. Remember when I took my picture and I cut it straight in half in between the parallel lines, I had two same exact pictures, right? So you can basically go ahead and copy everything down here. Angle 5 is going to be 50 degrees. Angle 8 is going to be 130. Angle 6 is going to be 130, and angle 7 is going to be 50. You can also take what we just learned about our corresponding angles. The corresponding angle to 1 is 5, and they have the same measure. Okay. Any questions on that? Okay. Look at example number 3. It says a furniture designer built the bookcase shown. Line A is perpendicular to line B, and measure of angle 2 is 105 degrees. Okay. So I can go ahead and fill that in. They want us to find the measure of angle 6 and the measure of angle 3. So of course they've already done the work for us, but we're going to go through and see what they said. Figure out why, how they got their answers. Okay. So it says that since angle 2 and angle 6, so if you look at angle 2 and angle 6 right there, they are supplementary. So I know that they add up to 180. So you can say that measure of angle 6 is 180 minus measure of angle 2, which was 105. So that means that the measure of angle 6 was 75 degrees. Okay. Does everybody see that? They're supplementary, so measure of angle 2 plus measure of angle 6 has to equal 180. And then, in order to find measure of angle 3, since angle 6 and angle 3 are what type of angles? What are 6 and 3?
Interior angles.
They're interior, but what type of interior? They're alternate interior angles, and remember, alternate interior angles have the same measures. So if angle 6 is 75, then that means that measure of angle 3 is also 75. You see that? I know it's kind of hard to see up there on the board. So then, B asked us to find the measure of angle 4. So we want to find 4 now. So how can I find measure of angle 4? Just by looking at all the measures that I've filled in there already. Let me zoom in a little bit. Do I have the measure of angle 4 up there already? Can I use the information that I have up there to tell what angle 4 is? What piece of information can I use? Andrew. Angle measure for 2. Why?
Because they're basically the same.
Why are they the same?
Because they're on the same point in the 2 lines.
So what is that, when that have, what are they actually called? Do you remember? If they're on the same part, the same spot, they're corresponding angles, okay? And corresponding angles have the same measure. So angle 2 and angle 4 are corresponding angles, meaning that measure of angle 4 is also 105 degrees. Okay? Any questions? Okay. Flip over. Okay, example number 4. Does anybody notice that my picture looks a little bit different than what I'm used to? It has more than one transversal, doesn't it? So my lines M and N are parallel, but then I've got this transversal, and I've also got this transversal. So, in the problem, it tells me that M and N is parallel. It tells me that line Q is perpendicular to line P, which this right angle measure right there tells me that, okay? They want us to find the measure of angle 7, and then they told us that the measure of angle 1 is 40 degrees. So I'm going to go ahead and fill in that information right there. Measure of angle 1 is 40 degrees. So if I want to find, I'm going to circle this one because that's what I want to find. I want to find the measure of angle 7. What do you think I can do? How can I find that? Lauren.
You could try to find the measure of 9 and 10 together.
The measure of what? 9 and 10.
I'm looking at something good.
Nick.
Try to find forward.
Angle 4? Okay, why do you think I want to find angle 4? Okay, so if I found 4, then I would have the answer to 7. But how can I find measure of angle 4? Can I? What about what if I look at this measure right here, 1, which I know, because remember, you want it, if that's what you know, you got to look and see what other measure is going to be equal to 40. Where else can I fill in a 40 down here? Okay. So looking at this one transversal line and my parallel lines, do I have any parts of this down here that I can fill in with 40 degrees? What? What angle do you think it is? Andrew?
4.
4? Can I use 4? It's cut by that other crazy transversal, isn't it? So it's kind of tricky. It looks like I might could use 4 as 140, but it's actually cut in half. 4 and 5 are cut in half. I heard 6. Somebody tell me 6? Okay. I like that. If I have this transversal and these two parallel lines, are those alternate exterior? Those are alternate exterior angles, and they have the same measure. So angle 6 is equal to 40 degrees. Okay? So now, can you find angle 7 with that piece of information? How?
You find a straight angle.
Uh-huh.
You subtract 40 from 100.
Okay. And what 3 measures right here tell me that they have to equal to 180? 6, 7, and 8, right? They all make that straight line right there. So if I add up angle 6, 7, and 8 and set it equal to 180, I should be able to solve for 7. Because I know that angle 8 is how much? Is what? 90 degrees. They told me that angle 8 is 90 degrees. I found out that angle 6 is 40 degrees. So 40 plus 60 gives me, or 40 plus 90 gives me what? 40 plus 90? 130. So then, how do I find 7? 180 minus 130. And what do you get? 50. So I know that the measure of angle 7 is 50. Okay. So it explains that right here. 1 and 6 were alternate exterior angles, so that's how I was able to say that measure of angle 6 was 40 degrees. And then from there, I found out that angles 6, 7, and 8 formed a straight line. So they were supplementary. So then you had 40 plus 90 plus x basically equals 180. So when you solve for x, you get 50. Does that make sense? That one's a little bit more difficult. Okay, let's look at example number 1 on the guided practice. It says refer to the porch stairs. Line N is parallel to line N. Angle 7 is 35 degrees. Find the measure of angle 1. So I'm going to go ahead and plug in my 35 degrees for 7. They told me that angle 7 is 35 degrees. They're wanting me to find the measure of angle 1. Somebody tell me what the measure of angle 1 is. Somebody say it. What? 35? Are they corresponding angles? Not quite. What is the corresponding angle to angle 7? Angle 3, right? If I cut this in half and put them on top of each other, angle 7 and angle 3 are in the same exact spot. You see that? So that means they have the same measure. So angle 3 is 35 degrees. Now can I find angle 1? I can. How can I find it? What are angle 1 and angle 3? What type of angles are they? No, not corresponding. Not vertical. They're not opposite from each other. They're adjacent. But what else are they? Supplementary. So if they're supplementary, what does it mean the sum of them adds up to? 180. So I could say measure of angle 1 plus measure of angle 3 equals 180. Okay? So let's write that down over here so we can solve it. Okay? Let's see. First, we found out that angle 7 and angle 3 were corresponding angles, right? And then I was able to find, or that's what we said, so measure of angle 3 was, what did we say it was, 35? Ooh, 35 degrees. Sorry. So then now that I know the measure of angle 3, we said that measure, or angle 3 and angle 1 are supplementary. So that means measure of angle 3 plus the measure of angle 1 equals what? 180. I already know that the measure of angle 3 was what? 35 degrees. So I have 35 plus the measure of angle 1 equals 180. So then when you solve for the measure of angle 1, what do you get? Good. 145 degrees. Does anybody have any questions on that? It's not too bad. You've just got to practice. You've got to memorize those vocab words, the different types of angles, what has the same measures, okay? And really just take apart each of those parallel lines. If you need to draw them in separate pictures like how we did when I cut them in half, it might make it a little bit easier to tell, to find your answers, okay? So if you need to do that, do that. All right, I want y'all to try to get through number 12 for homework, and then you'll do the rest tomorrow in class. So try to get 1 through 12 finished for homework. Number 9 you can skip. So 1 through 12, but skip number 9.